Okay, so here we go, everyone. We're given different flight paths for our angry bird who flies over. And we know that the vertical axis is the height, and the horizontal axis is the horizontal position away from that the bird flies. So, and we know the top one is b of x, the middle one, red one, is r of x, and f of x is the blue path. So based upon what we have here, the first part says estimate the vertex and the y-intercept of the black path. Well, looking here carefully, if I estimate that value, I'm going to say that that is 6.5, comma 10 as the vertex. This is the vertex. And maybe I should do it in black since I'm doing the black one. And the y-intercept, I can see that is right here at 0, 2. Now, if I want to use the vertex, calculate b of x. Well, because I know the vertex, it'll be easiest to use vertex form, which looks like this, where h and k are the vertex. So if I plug in my vertex, I know I have x minus 6.5 squared plus 10. And now my dilemma is I need to find a. In order to find a, I need to use some other point that I know, and I know the y-intercept. So if I plug in my y-intercept, I know my y value is 2, so this is y is 2, is equal to a, x is 0, minus 6.5 squared plus 10, which if I do that, I get 2 is equal to a times, well, 6.5 squared is simply 42.25 plus 10. Subtract the 10, I get negative 8 is equal to 42.25a. And so a, if I divide by 42.25, negative 8 divided by 42.25 gives me a value. If I convert that into a nice fraction, I get negative 32 over 169, which is approximately negative 0.189. So if I put it all together, I'm going to say that b of x equals, well, a is negative 32 over 169, and I did that with my calculator, of course, x minus 6.5 squared plus 10. And so the key here is you plug in the vertex you know, and then you need some other point. And it can be any point that you know to be on the curve. I could have used this point here, or estimated this point. Any of those will work fine for the curve. C part says, solve b of x equals 0. What does this mean? Well, if I'm going to do b of x equals 0, that means 0. So 0, and then I make negative 3 over 169, x minus 6.5 squared plus 10. And I'm going to solve this. And so I'm going to subtract the 10 is equal to negative 32 over 169, x minus 6.5 squared. Now let's get rid of my fractions. I'm going to multiply by 169. So that's 1,690 negative equals negative 32, x minus 6.5 squared. Now, because it's in this completely different square form, my trick that I've learned how to do is I'm going to, as opposed to setting it equal to 0, making one side equal to 0, expand this out, I'm going to divide by 32. And let's see if that works out nicely. I'm going to guess not. So we're going to say 1690 over 32 equals, and the negatives cancel out, x minus 6.5 squared and if I square root that, x minus 6.5, if I take the square root of both sides, don't forget the plus or minus, I end up with plus or minus, and I'm going to put this as a decimal, which gives me 7.28, plus or minus 7.28. And so x equals, adding the 6.5 plus or minus 7.28. So that means I have 6.5 plus 7.28, which is 13.78, or I have negative 0.78. So what does this mean? So if I estimate here, this value here is nonsensical. But the other value, if I would continue here, this value here, what does it mean? Well, the negative 0.78 makes no sense. It's no sense. But the 13.78 would be the point where the angry bird hits the ground. Provided he does not, if he stays on path, if on the current path. And that is where Angry Bird will touch the ground. All right, so make sure you understand what all these values are that you're finding. All right, then the final one, and let's make a copy of this page. Let's copy this page, clone the page, and I'm going to clear the ink. Okay, so now the last part says, estimate 3 points on the blue path and use those points to find the function in standard form. Well, so we're looking at the blue path. Here's a point here. That's a nice easy one, 0, 2. Here's a nice one, 3, 4. And here's another nice one, 10, 4. And the standard form, let me take those, move it down. Okay, standard form, as you know, looks like ax squared plus bx plus c. And so I'm going to plug these equations in. So I know that f at 0 equals 2. Well, I plug in my 0, it's a times 0 squared plus b times 0 squared plus c. And if I simplify that, I get 2 is equal to c. So I already know one of the variables. So I know that f of x is equal to ax squared plus bx plus 2. And I've used that point there. So now going on to our next point, we'll use this value here. So I know that this says f at 3 is equal to 4, which means my x value is 3. So it's a times 3 squared plus b times 3 plus 2. And if I simplify this equation, I get 9a plus 3b. And if I subtract the 4 over, I get negative, oh, actually, I'm going to subtract the 2 over, which means I have equal to 2 here. So there's an equation that I will use later. And so I've used this bit. And then finally I have f at 10 also equals 4, which means a times 10 squared plus b times 10 plus 2. And again, if I rearrange this, I get 100a plus 10b. Subtracting the 2 gives me 2. And here is a second equation. So if I have 2 equations and 2 unknowns, what I can do is I can then solve it. And I'm going to use my calculator for this. If I go to polysimultaneous, we're going to do number 2. 2 equations, 2 unknowns. And I plug my 9, my 3, my 2, and my 100, my 10, and my 2, and I hit solve. and I get my A value and my B value. Oh, let me, will be negative 1, 15, and 13 15s. And so putting this all together, I can say then that f of x is equal to negative 1 over 15x squared plus 13 over 15x plus 2. And that is the blue equation in standard form using 3 points. So from various models in the world, we can create quadratic models to fit and find out various information about it.